Okay, today I'm gonna explain about semiconductor material. To know semiconductor material, we need to know the first major thing in semiconductor material, which is the atom. The atom consists of four major parts in it, which is the valence electron, the electron shells and orbit, ionization, and atomic number. Four of these are the four major parts in an atom. Okay, let's move to the next one, which is the atomic number. Atomic number is the number of protons in nucleus. Elements in the periodic table are arranged according to the atomic number. The next one is electron shells and orbit. Electrons near the nucleus have less energy than those in more distant orbit. Energy distance, also known as orbit, from the nucleus corresponding to a certain energy level. In an atom, the orbits are grouped into energy bands, which are called shells. Difference in energy level within a shell is smaller than difference in energy level between shells. So, to simplify it, the difference in energy level within the same shell, within the same neighborhood, is lower than the difference in energy level within another neighborhood. That's the assumption I made for easier for understanding. You are free to accept it or not based on your understanding also. As saying about the electron shell, this is an important formula worth to remember. This formula is used to measure the number of maximum electron within an orbit. The next one we're going to explain is about the valence electron. The valence electron is an electron with the highest energy level exists in the outermost shell and loosely bound to the atom. The outermost shell is also known as valence shell. We learned this in high school. Electron in the valence shell is called valence electron, which is the electron at the outermost shell. Now we move forward to the insulator part. Insulators are material that does not conduct electrical current. Valence electrons are tightly bound to the atom, which is very few free electrons are available. The next part is conductors. Conductors are material that easily conduct electrical current. The best conductors are single element material such as copper, silver, gold, aluminium, and etc. Only one valence electron very loosely bound to the atom, which is the free electron. The next one is semiconductor. Semiconductor are material between conductor and insulator in its ability to conduct electrical current. In its pure, also known as intrinsic state, is neither a good conductor nor a good insulator. Most common semiconductors are silicon, germanium, and carbon, which consist of 4 valence electrons. Next, we move forward to the energy band diagram for insulators, semiconductor, and conductor. Okay, now I proceed to explaining about the insulator first. As you can see, the energy gap between the valence band and conduction band for the insulator is quite high. So, the energy needed for the free electron to jump to the conduction band is tremendously high, which is you can safely assume that it's quite impossible for an electron to obtain such energy in order to jump to the conduction band. So, you can safely assume that this is an insulator energy band. The next one is semiconductor. As you can see, the energy gap between the semiconductor and insulator is a little bit closer compared to the insulator one. So, the energy needed by electron in order to jump to the conduction band is specified to the certain elements, such as for germanium, it needs 1.1 electrovolt. For silicon, needs 1.1 electrovolt. Energy needed for germanium is 0.67 electrovolt. And energy needed and this is the energy needed for this element in order for the electron to jump to the conduction band, thus allowing the current to flow. Next, we move on to the conductor one. As you can see, the energy band for the conductor energy band diagram is overlap between the valence band and conduction band. Thus, this allows constant current flow by allowing the electron to constantly jump from the valence band to conduction band, which result in a good conductor. The next one is the conduction in electron and holes. As you can see in the diagram, on the left side is full of holes, where on the right side is full of free electrons. When the voltage is applied, free electrons are free to move randomly and attracted towards the positive end. This movement of electrons is one type of current in semiconductor, and this is called electron current. When current is applied here, the electron got excited due to meeting the same charge, thus allowing them to jump to the hole, and next forward jump to another hole, thus completing the circle, allowing the current to flow. Last but not least is the N-type semiconductor. N-type semiconductor are pentavalent impurities that are added to silicon or germanium, result in the increase of free electron. One extra electron becomes a conduction electron because it is not attached to any atom. The number of conduction electrons can be controlled by the number of impurity atoms. Pentavalent atom gives up an electron, called a donor atom. Current carriers in N-type are electrons, which is the majority carriers, and holes, which is the minority carriers in N-type semiconductor. Holes are created in silicon when electron, which is hole pair, are thermally generated. As you can see, one electron of silicon is paired to another 4 electron. One atom of silicon is paired to another 4 atom of silicon. So, after the covalent bonding, result in one electron free. The one electron is called the donor. The one electron is called the donor atom, which is the free electron. Here, this is the diagram for N-type. Okay, last one is P-type semiconductor. P-type semiconductor are trivalent impurities that are added to silicon or germanium in order to increase the number of holes. Boron, indium, and gallium have 3 valence electrons. They form a covalent bond with 4 adjacent silicon atoms. A hole is created when each trivalent atom is added. The number of holes can be controlled by the number of trivalent impurity atoms. The trivalent atom can take an electron, which is an acceptor atom. Current carriers in P-type are holes, which is the majority carriers. Electron minority carriers are created during the electron hole pair generation. You see, this electron is paired with 4. This atom is paired with 4 other electrons, resulting in one hole. This hole is the majority carriers for P-type semiconductor. And this is the diagram for P-type semiconductor. And that's all from us. Thank you, and may the best of luck in your exams.